All right. So what is linear regression? We discussed about the linear regression in the past session. I just started and then I just gave you an overview of the regression problem and the two types of problems and the supervised machine learning we discussed. So can you all type it in the chat window? What are the problems we can solve as part of supervised machine learning? Can you make it fast? Supervised machine learning. Yeah. Yes, Mukhilan answered correctly. How about others? How about others? And regression and classification. So using linear regression, we can solve the regression problem. Using linear regression, we can solve the very good Mala. Okay. So using linear regression, we can solve the regression problem. Okay. And what, so, okay. So now the question is using linear regression, we can solve the regression problem. So why don't you give me some example for this? Yes, Sarana, very good. Okay, we can solve for regression. Okay. So give me an example for the regression problem. Okay, tell me what is linear regression? We discussed linear regression. Using linear regression, we can solve the regression problem. Apart from that, how we can define, how exactly we can define the linear regression. What is the advantage of this? Regression quantitative variables. What do you mean by regression quantitative variables? Quantitative variable is fine. What is regression? Regression quantitative variables. Predict dependent variable using independent variable. Very good. Right? Mala has typed correctly. Predict dependent variable using independent variable. No, predict. Correct. Using independent variable. Okay, or we can predict the value of a variable based on the value of another variable. We can say that value also, right? That we also. We can predict the dependent variable based on the value of the independent variable. We can say that way. That is, basically, you can see a lot of different definitions floating around in the net. But this is the everywhere, right? So the context is similar. Linear regression is to solve regression problem, and for that purpose we are using. It focuses on the relationship between independent and dependent variables. Relationship between these two things. Okay, and also using linear regression, we can predict the dependent variable based on the independent variables, and it gives us linear regression also gives us a sense of how changes in individual drivers affect the outcome. Okay, this okay, so how it gives us, it gives us a sense of how changes in individual drivers affect the outcome. Okay, this is very important. Okay, so this is the, right? So what we do is we will try to quantify. We can do, we can make what if kind of analysis with this. Okay, by knowing, how much each slope value is influencing the outcome variable, right? The slope determines. Okay, that we will discuss it later. Okay, now the thing is, look at this data set. In this data set, can you tell me, which one is a dependent variable, which all variables are independent variable? This is the housing data set. Okay, so this is the realtor. Okay, he's a realtor. He's into realtor, realting business. Okay, real estate business. and the manager wants to make a key decision, and he has to predict the housing price for these given specifications. Okay, the square feet of the house is 1,000, and the age of the house is 2 years, and number of bedrooms are two. And if the house is in so and so area, and if the number of lights in the house is so and so, and what is the estimated housing price? He has to give this one in a matter of few minutes, 5 minutes time or so, to his management. Okay, yeah, he need not to go to this place in person. Simply he has all the data what he needed, the size in square feet, age, all these variables are there, and now he wants to estimate the price. So what is the dependent variable here? The dependent variable is price. Yes, very good, right? So Mukilan, correct, right? So the independent variables are dependent variables. Number of, no, it's not the number of bedrooms area is not dependent variable, independent variables. Okay, I think you wrongly typed it, right? Mistakenly typed it. So these are the variables are independent variable. This is my dependent variable. Correct? Okay. And the next one is, so using linear regression, what we are doing is we are training this algorithm with the historical data, and then we apply the learned algorithm on the unseen data. Okay, so there are two steps. In the last session also I discussed it. I will repeat it one more time. Training, right? You need to train your model. Model with historical data, step one. And once you train the model, we call this a learned model. Learned model. That's all. So now you train the model with the historical data. Step one is over. Now the model learned the pattern while it was being trained with this data. And then now I call this a learned model. Okay. And the next step is I'm going to apply this model on the unseen data. Apply this apply this learned model on this unseen data. See, if you go and tell someone, okay, I developed a linear regression model. So people will say, what is so big deal? A lot of people already developed the model. If you go to github.com, a lot of Python scripts are there. What is so big deal? So you did not develop regression algorithm itself, right? This algorithm was developed by someone else. What is so big deal? No, I trained my model. Now my model can predict whatever value you can give. Okay, so let's say if I throw some numbers like this, your model should give me the predicted value for this one. Okay, this is called your test data. Okay, so let's say I call it training data. This is my test data. So in real time scenario, we cannot say test data, is a live data. Okay, live data. Okay, so live data it will come. Okay, it's a very simple one. So what we are doing is you all understood, right? I don't want to repeat, but if you concentrate here, I think you should be able to understand. In the interest of video quality, I'm not going to, I'm trying to avoid wherever repetitions are there. Okay. If you still get confused, one second. Okay. Okay, this is not, yeah, in this case, I mentioned about unseen data. Unseen data in the sense, right? See here, in this case, yeah, so with this diagram, sorry for the confusion. See, as per this data set, right? So we have the independent variables and dependent variables. It's not unseen data. Please ignore this, okay? I was just thinking that, blindly, I put another diagram in other slide. Still, I was, having that in my mindset. See here, there is no unseen data. First, we train the model with the independent variables and dependent variable, right? So that's all in this case, okay? And the model will get, trained with this historical data. We are giving the input as well as the output. Okay, what is input? The independent variables are your input, and the output are your dependent variable. They use different terms. You're not supposed to get confused. Hence, it is mandatory. You need to keep watch my video. The advantage here is I comprehensively cover all the terms in a single video. You don't have to go through 10 websites and see that. Okay. So input and output, when you give it, the model can learn. That is what we have been talking since the beginning of the machine learning topic, right? So since, right now, once you train your model with the input and output variable, it will become a learned model. We call it a learned model. So henceforth, and if I say learned model, this model got trained by both input and output variable or independent and dependent variables. Okay, so that is what it meant, learned model, and then apply the learned model. For example, I have another set of data. Okay, let's say somebody is giving me the data which were not there in this one. Somebody gives me 800 square feet, and age of the house is 6 years, and number of bedrooms are 3, and the area is something like 12th Avenue, something like that. Okay, they're giving me, hey, okay, you said you trained your algorithm, your model, linear regression model predicts with higher accuracy. Can you give me the estimated housing price for this specification? This is the input variable. In this case, he is not giving me the price. Okay, all I have to do is I need to apply this learned model on this unseen data, because this data my model was not seen. Look here, this data is not there. Maybe we have more number of records. Let's I trained this model with 10 m records, 10 million records. Okay, but this specific thing, it was, let's if it is not there, will my model predict? Yes, it will predict. Okay, how accurately it is going to predict? Okay, that is what. So first of all, the step is, right, the first step is you train the model and then apply the model on the unseen data. If anybody asks you for this specification, hey, give me the price, I don't know price. So your model should give the price based on the input, whatever you have shown it to this model. It is as simple as that. And if you ask me another question like, no, it is going to be 1,200 square feet, and the house is 5-year-old, and the number of bedrooms are 2, and some street name. Okay, so for this house, can you give me the estimated housing price? Yes, it should give some number. Okay, predicted value it will give. Okay, but how accurate are they? That is a different topic altogether. We will discuss it later. Okay, and okay, the next one is, so the idea here is, what are the steps involved here? The first step is train the model and then apply the learned model on the unseen data. That is very much important. In the case of supervised machine learning model, we need to split the data into train and test data set. That we will discuss it little later. And also we discussed about the types of relationship, right? So we use something called correlation. When it comes to linear regression, all your independent variables should be linearly correlated with your target variable, target or your dependent variable. Okay. In this case, we plot it on a scatter plot. So this is my positive or negative correlation, because we can see like there is no relationship exists between these two variables. And next one is, we will take a look at the two different types of linear regression. The one is the simple linear regression. As the name suggests, it will have only one predictor or only one independent variable and only one dependent variable. And if you guys think, right, it is confusing me if you use different terms, still we are new into this. Probably what I will do is I will stick to this one, right? Independent and dependent, all of you aware of it, okay? But still, you should be familiar with these terms. They will be using, different terminologies once you get into a real-time project. And what is multiple linear regression? On the contrary to simple linear regression, here we will be using multiple independent variables, more than one independent variable, and one dependent variable. Okay, that's all. That's the difference between these two. But in real life scenario, we don't use simple linear regression, as I discussed already. And these are the examples or use cases I've given you already. And okay, give me some other examples for linear regression. Forget about the real time thing, no? So simple example like, okay, Give me some other examples. So what kind of regression problems we can solve? Let's say, the age of a person. Does salary, depends on age or something like that. Okay. This is a dependent variable. I wanted to predict the salary. So age is an independent variable, right? This is one example. Okay. So this is the predictor or the independent variable which helps me to predict the salary. So in addition to age, what other things can help me to better predict the salary? See, in the government organizations, in the past, even nowadays, even the government organizations, they made a lot of changes. But I'm not sure, what changes they made it. The basic thing is the age, and they need to complete some exam. When they complete some exams, right, they can go for the next level. The same is applicable in the software industry. Take for example, in the software industry, right? Age is not at all a matter. Okay, so whether young or old doesn't matter. And what is your performance, right? Performance. Okay, or your top or rating, right? Your rating, and then age. Okay, but just for example sake, okay, we'll keep rating plus age and probably certifications. What are the certifications that you completed, right? So the more the certification you completed and more skill sets that you have, right? More skill sets, Python, PySpark, and Hadoop, and the Power BI, and uh, uh, the Hadoop Hive data warehouse, Spark. If you know more skill sets, the salary is more, right? That's a common phenomenon. But of those, individual variables or independent variables, which independent variables are very much helpful in terms of predicting the salary, or which independent variables have a significant, if impact on my salary, right? We can see that one. So in simple term, multiple linear regression, right, in that case it will involve more than one independent variable. This is another example for use cases for linear regression. So predict the salary. And so another simple example is weight. As we grow older, our weight also increases, right? Yeah, experience, right? Yeah, my experience, very good. That's what age is, kind of, instead of saying age, experience, right? Experience, yeah, that's a very important parameter, correct. Okay, here is the equation for linear regression. Okay, you remember in high school, we studied an equation y equal to mx plus c, right? Y equal to mx plus c, something like that, okay? And here, so the y is a function of x, something like that we have studied. But here, right, so in the simple linear regression, we use this notation, beta naught, beta 1 and all, instead of MC and all, right? We use beta naught and beta 1. So y is called your response variable or dependent variable. And this is your x is your independent variable. Okay, this is your dependent variable, independent variable. Any of this study material, will be made available as part of my existing website, and you can refer the other terms. Okay. And the next one is the model parameters. These are called my model parameters. The beta naught, beta 1. So beta naught is your intercept and beta 1 is your slope. And now let us take a look at, visually to understand this equation. So what is an intercept? So we know very well what is independent variable, dependent variable, right? There is no point in keep talking about. So well, let's say a housing price. Let's take the same example, simple example. Housing price, and this is my age of the house or something like that. Okay, so this is a pretty straightforward. What is beta naught, beta 1? Beta naught and beta 1, these two, the values for these two variables or parameters are determined automatically by the statistical softwares. We don't have to manually compute this. However, if you wanted to compute it manually, that is also possible. We have formulas available for this one. First of all, let us understand what is beta naught. Beta naught stands for intercept. Beta 1 stands for slope. Okay, this is intercept and this is slope, and this is CH. Okay. So now the question is, what is these two terms? I'm completely new into this intercept and slope. So these two are called also called as model parameters. In general, they call as a coefficients, model coefficients, or beta coefficients. So these two are called your beta coefficients. So what is intercept? So now you know all the things. Forget about E error. Okay. And what is beta not beta one? Intercept. So what is intercept? So if you see on the x-axis, we have plotted a variable called advertisement, and the y-axis we have plotted a variable called sales. If I spend more money on advertisement, obviously you can expect more sales. Unless your product is visible to the audience or public, how can you market your product? Right? First of all, your product should be uh, the product identity should be made. You should say someone, right? These are the product I'm selling it. Unless people know about your product, how can you market it? How can they come and buy it? Right. So to spend more money on advertisement, obviously sale can also go. This is a common phenomenon. Again, there are a lot of other factors. Let's take with the simple hypothetical case. Let's say, if you spend more money on the advertisement, obviously the sales, and somebody, let's say in your company, yes, obviously when I spend more money, the sale is more, but I'm having a budget constraint. I cannot spend $80,000, $100,000. So if I spend so and so amount, how much sales I can expect? If somebody is asking you, okay, let's say I want to achieve $700 sales. No. If I spend $700 in advertisement, how much sales can I expect? If I ask you this way, if I spend $700 in advertisement, because this is my budget. Let's say my budget is anywhere between $700 to $800. I don't want to spend upfront the 800. Let's say, I would just want to do some kind of analysis. If I spend $600, what is the expected sales or estimated sales? If I spend $700, what is the estimated sales? Somebody is asking you. With this, you can tell quickly what is the expected sales. So why don't you type quickly in the chat box, what is the expected sales if I spend $600 in advertisement and $700 in advertisement, how much I can increase in find the how much I can see the sales. I'm sure I discussed this in the last session. Look here, this is the straight line, right? The linear, this is called your regression line. Okay, and this is a line, best fit line. It is also called as a best fit line. So here, if I draw a line, listen here, right? So this is straight line. So it's all let's in 10,000 sales in 10,000. So which means 50,000, something like that. Okay, and here let's 50,000. It is something around 60,000. Okay, 60K something like that. If I spend $600, I can expect 60,000, something like that. Okay, and similarly, if you draw the lines here, right? So the line, you need to draw a line vertically till it touches this best fit line, and then if you draw a line horizontally towards your x-axis. So this is what. So if you spend $700, you can expect 70K. If you spend $600, 60K. Okay, so this is the one. Okay, and you can tell the estimated sales. just by drawing. And if I have millions of records, you can draw each and everything. And can you do it like this? It's not possible, right? So we have something called intercept, and we have something called slope. What is intercept? The line where it, the best fit line, this line, I'm talking about the straight line. The line where it touches or crosses the y-axis. Your y-axis is called your intercept. This is what your intercept. Okay, what is the formula for the intercept? This is the one. So the mean of your y value, the average of your y value. For example, in this case, housing price. Okay, no, in this case, sales, right? Average sales minus your slope into the average of your independent variable, which means advertisement expenses. The average advertisement expenses. That is what your intercept. Okay, so the line where it touches the y-axis is called your intercept. Okay, so that is what. Okay, the next one is slope. We have something else called slope. What is slope? Slope is nothing but the change in what is the rate of change in y when x changes. What is the rate of change in y when x changes? That is what your slope is all about. Okay, I'll explain you with example. Don't worry. And this is the formula that we use to find out the slope. And alternatively, you can use this formula also. Okay, you can use this formula. So guys, you don't have to remember these formulas to fit a model or to train a model. These two terms are same. Don't get confused. Okay, but here the formulas are same. The interview, they'll ask you what is the formula for intercept, what is the formula for slope. Though the value for these two are computed by the statistical software or packages, but still they'll ask you whether you understood the formula correctly or not on the underlying mathematical formula, right? They will ask you this one. But it's always good if you understand the formulas, but there are some cases you don't have to. If you want to compute it manually, you can simply put all the, so what is your the x independent variables value, what is your dependent variable value, and you put it here, and x minus x bar. So mean, find out the mean, and then y is the mean for x and y. That's all. If you know the mean for x and y, x minus x bar and y minus y bar and x minus x bar was there, likewise you can find it out. Yeah, some the building work is going on here. Nothing can be done. I just closed my window and hope it will not cause any more issues. Even I was finding difficult, headache and all is there. Okay, so what is this slope and intercept? The slope and intercept, that is the one define the really relationship between two variables. Okay. So what is a slope? As I told you, slope is nothing but the rate of change in y as x changes. We can say that way also. That is what your slope. The slope estimates the average change in the responsible variable or average change in the dependent variable for each unit. Okay, then you don't worry. I'll explain everything. Don't get confused. Okay. See, in simple term, so for for every 1 unit increase in x, how much increase I can see in my y. That's it. That is what your slope. And I'll give you with one example. For example, I want to predict my auto fare. Let's say you are using Uber app or Ola app in your mobile phone. And let's say your equation. This is your y. Okay, you want to predict the auto fare. How the app is predicting the auto fare. Okay, here let's say in the 18.23, this is your intercept value. As I told you, the intercept, you don't have to compute it manually for interview purpose, and also to understand the underlying principle. If you know the formula, that is good, but we don't have to compute it. Let's say the intercept was computed by my model automatically. and my slope was 2.23 and into kilometer. Now tell me which one is independent variable, which one is dependent variable. Make it fast, make it fast. So this is my linear regression equation. Y is equal to beta naught plus beta 1 into. So now you tell me which one is independent, which one is dependent variable. Kilometer is independent. Very good, right? Taruna, okay. And Mukhilan, dependent auto fare. Very good, good, right? So, fine, right? This is my dependent. So let's say if I want to travel 100 kilometers, okay? And simple, very simple, 100 into 2.23 plus 18.22. This is the estimated. This is the estimated average. You need to say average, okay? Average auto fare. Estimated average auto fare, okay? So now the question is, price is dependent. Yes, very good. Price is dependent, okay. Somebody typed in the chat window, that's what I repeated, okay. Estimated average auto fare was this one. If you 100 into 2.23, how much? 100 into 2.23, how much? 223, yeah. 223, right? So 223 plus your 18.23 plus 18.23. So this is your 241 rupees 23 paisa. This is the estimated average out of it. With this simple linear regression, we are able to estimate the average out of fare. Now the question is, what is the role of slope here? With the help, this is my slope. This value also determined by my software. Okay, so here, how we can interpret this then? Okay, what is the, okay, now if somebody is asking you, okay, what is the rate of change in Y when X changes? See, that is what, okay, let me go back here. See, as we spend more, let's go back to the previous example, advertisement and sales, right? And as I invest $200, the price go. So as $300, how much? Let's say if I invest $325 in advertisement, how much sale can I expect? Right? So as the X value increases, obviously the Y value also increases. But the slope helps us to understand what is the rate of change in Y when X changes. Okay, what is the rate of change in Y when X changes? So that is what the the slope is. That is why the slope is very much important here. With this, we can find out that one. If the slope is 2.23 here, then when a kilometer increases by 1 unit, or there is a 1 kilometer increase, the Y, the auto fare increases by 2.23 rupees. Okay, for 1 unit increase in kilometer. Okay, or for every 1 kilometer increase, for every increase in 1 kilometer, what is the increase in my auto fare? In this case, it is 2.23. Okay, in this case, the slope is, let's say if the slope is 3. If the slope is 3, so what is the rate of change in Y for each 1 unit increase in X? If somebody asks you, what is your answer? 3, right? For every 1 kilometer increase, so for every 1 kilometer increase, right, there is a 3 rupees increase in your auto fare. Supposing you want to travel, in this case 100 kilometer, right? If I ask you what is the estimated average auto fare for 101 kilometer, what is your answer? Forget about this one. Take 2.23. What is your answer? 101 into 2.23, right? Or can I say 241? Already we are right. 241.23. Can I simply add 2.23? Does it make sense? Does it make sense? Okay. So in simple term, the slope estimate the average change in the responsible variable or the output variable y for each one unit. That is what it tells us. We hope with this you are able to understand what is slope is all about. Okay, or we can, what is the change in y? The change in y divided by change in x. We can say that way also. But what is the rate of change in y when x changes? Right? When this x changes, what is the rate of change in y? So that we can quantify with the help of slope. Next one is intercept. What is intercept? So as I told you, the line where it touches the y-axis is intercept. But if you tell this to the business users, they will not be able to understand. They are very particular about the numbers. They don't care about the theory and where the line crosses, touches, and they don't care. Then the business, company CEO sitting next to you and asking you, hey, give me the estimated, sales value if I spend, money on so and so thing, right? So they will ask you that. So if you say, and if you ask you that, what is intercept? So in that case, the intercept is nothing but the average. Say, for example, okay. So let's take another example. I think I mentioned it here. Okay. See, sometimes the intercept, value is not much, helpful. I'll tell you why a little later. For example, I have something on sales. I want to predict the sales, and my intercept is 18.92, and my slope is 2. And let's say, advertisement. Okay, we give advertisement in TV. If I invest $100 in advertisement, what is the estimated average sales? I can say it. So let's say $100, you're investing 100 into 2, 200 plus this one. This is the estimated sales you can expect. This is how you can quantify. This is the average estimated sales or predicted sales, you can tell them. Okay. And supposing if I don't invest any money on TV, right? So TV is 0. This month we did not do any advertisement on the TV, 0. So 0 into 2, how much? 0. So this part has gone, 18.92. When x equal to 0, what is the value of y? That is what your intercept. When x equal to 0, what is the value of your y? That is what your intercept. We can say average value of y when x equal to 0. That's what I have, phrased it like this. Average value of y when x equal to 0. In this case, the x is my TV. The x is nothing but the independent variable. Okay, so this is 0. If this is 0, so when x equal to 0, what is the value of y? That is what my intercept. Okay, in this case, the intercept really makes sense. Okay, even if I don't give any advertisement, that doesn't mean I will not have any sales. Okay, even if I don't give any advertisement, still sales are happening in my shop. But if I give advertisement, I'll get more. That is a different thing. But if I don't give advertisement, still business people are coming and buying it from my shop. In this case, the intercept really makes sense. There is another scenario. Let's say take the same auto fare. If I travel 0 kilometer, this one will become 0. and the estimated auto fare is 18.23. If you ask your model, hey, if I don't travel if I don't travel, what is the estimated auto fare? If your model says you need to pay 18.23, in this case, does it make sense? No, right? Sorry, yes. So yeah, so in this case, the why sometimes it makes sense, the intercept, sometimes it is not, it doesn't much helpful. But when you use something else called one hot encoded variable, okay, one hot encoded variable, right? So in that kind of situation, the intercept really plays a crucial role. Okay, that we will see it later. Let's go step by step. Hope you understood what is slope and what is intercept. Okay. See, the classic example is out of Jeevan. For you only, I took this example. Okay. If somebody travels 100 kilometers, these values are already computed by a model. I don't have to do anything, math or anything. Okay. Simply plug in the value 100, 100 into this one. This one, this is the estimated, average estimated out of fare. You need to include average. Okay. Estimated average out of fare. Okay. So this simple linear regression equation helps us to predict the target variable. So it is also called as a target variable out of fare. Okay, target variable or dependent variable. Okay, and if somebody is asking you, okay, for every 1 kilometer increase, how much the out of fare will increase? If somebody is asking a question like this, what will be your answer? With the help of slope, you can tell 2.23. For every 1 kilometer increase, the out of fare will increase by 2.23. This is what is called as rate of change in y, right? So the what is the rate of change in y when exchanges by 1 unit, the out of fare will increase it by 2.23. We can say that way also. You can rephrase it, right? Whichever state sentence that best suits you. Okay. Now you understood what is the intercept and this one. Okay. If I say something like the intercept value can be a negative also. Intercept can also be a negative value. It can the even slope can also be negative. It need not be positive all the time. Okay. It can be negative or positive also. Okay. The next one is look at this one visually here. For example, I have two observations are there. Two values are there. Okay, I plotted it in in this x-axis and y-axis. The same thing, sales and advertisement. If I draw a line, right? So it touches, this single line touches these two values. If I have only two values, drawing a straight line is pretty simple. If I have more than one value like this, so how can I draw a line? Can I draw a line here or can I draw a line here? Can I draw a line which touches the top three values, or can I draw a line somewhere in between these two, all these values? Right. So which one is the best fit line? This is the best fit line, right? This is the best fit line. Okay, because this line is drawn as close to as many data points as possible. Rather, if you draw a line on top of this one, these two values will fall far away from this line. If you assume that you are drawing a line like this, okay? Instead of, if you don't have this line, if you have drawn a straight line, assume that is a straight line, okay? So okay, this line touches all these three values, but the problem with this line is it is too far from the other values. Rather, if you draw a line by touching only these two values, yes, that line is touching these two values, but other three values are falling far from this line. So if you draw a line somewhere here in between, so if you see the, this line is somewhat closer to this one is closer to this one is closer to this one is closer to this one, right? Otherwise, let's assume that if you are drawn a line here, the distance is this much, right? But if you draw a line in between these two, if you go by this line, this is closer to this one, this is also somewhat closer, right? So this is kind of an unbiased line. Okay, it is though this line is not touching the above line, above three observations or below thing, but it is drawn in between these two, but it covers almost all the observations. So the best fit line, so we have something called best fit line. The best fit line is something like the line which is drawn as close to as many data points as possible. The error will be very less. Okay, the error will be less. First of all, what is an error? For example, I have shown you, right? We have drawn a line here, between all these 5 observations. Instead of drawing a line on top of this one or here, if I draw a line in the middle, what will happen is the distance between this value and this line is very less. Okay, why should I find out the distance between these two things? So this is my actual value. The predicted value sits on top of this line. Here, okay, so here the predicted value. So we are going to find out the distance between actual and predicted value. Actual, this is very important, remember this, actual minus predicted is called your error. Error, or some people they call it residual. Forget about residual. Let's talk about error. Okay, so actual minus predicted is called error. The distance between actual and predicted is called your error. Okay. Okay, so here okay, so if you recall this one auto fare, if you recall auto fare, so kilometer, let's in Excel sheet somebody has given you km. Okay, if it is if the distance is 101, 202, and 58 kilometers, 62 kilometers for all these 4, and another one is 117. For all these 5 different kilometers, can you give me the estimated auto fare? So this is what is called your actual. It was given by your manager. So what you need to give him? What do you need to give him? Predicted values for this predicted price, auto fare, predicted auto fare. You need to give him the predicted auto fare. Sorry, this is not actual kilometer. Sorry, we'll say this is okay. Let's say he has given a kilometer. Okay, forget about actual. Okay, this is not actual here. So the kilometer he has given you 101, 202, 58, 62, 117, and also he has given you the okay, here the predicted auto fare. Okay, you need to find out the predicted auto fare. Okay, for each of them. Okay, the line I was talking, right, on top of the line, the predicted values will be there. So who is going to predict the value? It is taken care by model. You don't have to worry. We have something called predict function. Using a predict function, we can predict the estimated auto fare. Remember that. Okay. So, but this is my independent variable. How many values are there? Okay, this is my actuals. You just think, think something like that. 101 or something like. Okay, so in the case of sorry guys, I just I thought of giving some other example. Okay, let's say your manager is given you something like this. Instead of, let's take another data set. Okay, this is your kilometer, let it be there, and then price is giving you, okay, and it's already given to you, and you have used some prices, okay, and 100 and 200 and let's 60 and 65 price also you given, because you need to give both the input and output variable in the case of supervised machine learning model. And let's he is given 128 something. This is your actual price in the sense auto price fare, okay, actual fare. He has given you both the kilometer as well as the price, okay, and he wants you to give the estimated auto fare, okay, or the fare also is given, okay, estimated, predict the thing, okay. Okay, now what you do is you train your model with this thing, and then you will predict the estimated model, estimated price auto fare. If I go back here, what is my actual value here? The actual, the auto fare, right? Given by my manager. Let's it's 100, and here it is 68 years given, but the predicted one is 78 by my model. Okay, by my model predicted with value for 78, and he has given 68. For and this one is you just assume that this is your kilometer, okay, and then this is your fare, auto fare. Okay, and here likewise for 5 values he has given, right? For each value we need to specify the prices here, okay. So to understand this one, this is the actual price and predicted price, you can say like that. Predicted fare, actual fare and predicted fare. This is the predicted fare, this is the actual fare, this is the predicted fare, actual fare, because you have 5 records, five records you need to predict it, right? So he has given it. So now the question is, what is the difference between actual and predicted fare? That is what is called your error. Okay, this is my actual and this is my predicted. So now you might be confused. Why should I estimate the predicted price when the manager has given me the actual auto fare along with the kilometers? Why should I still predict it? Why should I predict it? Let me see how many of you can think correctly and tell this one. So in this case, we are using single independent variable kilometer. Okay, and let's say in the case of multiple linear regression, you have more than one independent variable. So you have something called let's say 18.3 plus the 2.23 your slope, and then what is this? This is kilometer, right? Kilometer. And what other factors can drive the fare, auto fare? What other fares, fare, auto fare? So does only kilometer can influence the auto fare? Any other thing can influence the auto fare? Time on peak seasons, very good, right? Peak season, excellent. And then traffic, okay. Petrol price can also, okay, independent variable, right? So petrol price, we can see it. And then let's the waiting time, right? Waiting time, when you wait more time, and then there's another variable called wait time. Waiting time. So your waiting time is let's say 0.33 is the slope. For each independent variable, your slope will be computed. Okay, this is my another independent variable. IV means independent variable. And for each independent variable, slope is computed. Okay, computed. For this wait time, the slope is 0.33. For this kilometer, the slope is 2.23. Okay, so now if my manager, just because he gave me the price for so and so kilometer, the actual price. If somebody travels 100 kilometers, this is the price. One or two, for the sake of instead of going back and forth, I'll write it here. You have five records, 5 data he has given. 1, 2, 3, 4, 5. And somebody, if somebody travels 80, and we will make it 90 rupees. This is the price. It's also fare. Okay, he's given you the fare with the distance, everything, and this is kilometer is given you, and wait time also is given you. But at any point in time, if he ask you, if there is a 1 hour wait time or 2 hour wait time, and what is the if the distance is 500 kilometer, what is the estimated auto fare, right? Are you able to understand what I'm trying to say? The context. This is my actual fare. This is the kilometer, and here let's 117, 218, 113. These are the kilometers given. For this kilometer, he has given you the price also. 100, 150, to 120, something like that. Okay, he is giving you the actual fare also. This is my actuals. So look here, this is my 102 actual. And what is the predicted? So predicted out of fare. Predicted out of fare, how can I obtain it? How can I obtain it? With the help of this equation, the right side of the equation gives me the predicted out of fare, right? So this equation. So I call this a y hat, right? So the y hat is nothing but the right side, the predicted value, predicted out of fare. Okay, and if you plug in the value, for example, in this case, 100 kilometer, and the wait time is, it can be anything. See, now the question is, I was asking to this one, and see the actual price is given. Let's say even for this so-and-so wait time and so-and-so actual price and so-and-so kilometer, this is the fare is given. Then why the hell should I need the predicted fare? The reason why we need is at any different point in time, or at any point in time, right? The number of kilometers and the wait time will vary from time to time, person to person. Like he mentioned, traffic, right? During the peak hours, how much, right? It is very dynamic, right? If you ask questions in any combination, still my model should be able to, give you the estimated auto fare, right? That is where uh, the predicted fare is predicted values, or that is where the machine learning models are very much helpful. In this case, the linear regression model is very much helpful to quantify for any given different values. Still, you can estimate the outcome variable. Okay, with the different combination. For example, okay, you tell me the auto fare only if the number of kilometers 200, and if the wait time is 2 hours. Okay, plus you have something on traffic condition. If it is a peak time, and if the peak time, and again peak time also, let's say morning 8:30 to, let's 11. If somebody is asking you randomly your model, right? So let's say everything is available web browser, in your browser, or see, forget about browser, yeah, Uber app, right? Uber app, you simply enter your the place where you board the vehicle and the destination. That's all, right? It gives you the estimated wait time and then the fare, everything, right? And also because of the heavy traffic causing, it tells you because of the heavy traffic, the wait time is so and so, and it estimates the wait time also, right? The driver, what time he can reach. All these things is estimated, given any different combination of situations. With the help of the model, we can make a prediction with any with the different possible combination of variables. We can make a prediction, right? We can get the estimated target value. So that is the advantage of using the regression model or the machine learning model. You got it? So that's what. And again, you cannot so for example, here 180 to 117 to 118, and somebody is asking a question which is not there here. You say if I travel 72 kilometers, if I want to travel 72 kilometers, and in between I will stop for 10 minutes or 20 minutes, and that to peak hours, what is the estimated out of fare? You will not ask in the app, you will just type it. So what it does is, okay, it automatically computes the distance also, right? The distance is 72 kilometer, and the wait time is, so he mentioned somewhere he stopped somewhere, and then he waited for 20 minutes, and then the peak hour, he waited somewhere, that's a peak hour. And automatically, though these values are not seen here, not appearing here, still for any given value, you should be able to predict the target value. That is the beauty of the machine learning models. In this case, the linear regression model is, though it is a very oldest algorithm, with this you can do a what if analysis, and you can quantify, what if something goes high, or what if something goes down, what is the expected outcome, right? You can find out with the help of linear regression. Though it is a very oldest one, still it is very good. Okay, you can do a lot of quantification, and especially when you present it to your management, they will be very happy. They'll ask a lot of questions like this. So not only developing a training a machine learning model and testing it out, and let's after all the things, your model accuracy is good, and finally you are going to present it to your company stakeholders. So that point in time, if they ask you, with this, what if I increase only my kilometer? Let's say the kilometer is 200 kilometer, and sometimes offer price will be there. Okay, and so thing, right? Special customers or loyal customers, we'll give some discount, predict the discount also, right? Those kind of situation, they will do the combination of more, they will do analysis with the multiple combination of variables. So that kind of situation is very much helpful. With this, we can, with the combination of more than one variable, we can estimate the outcome variable for any given input value. So what is best fit line? So best fit line, the line where it covers as many data points as close to as possible. That is what called your best possible line, and best fit line. If you see here, the distance between actual and predicted is less. Okay, here it is less. Less in the sense, if you draw a line somewhere here, right, somewhere here, it will not be. So in this case, the best fit line should make sure that it covers all the values and as close to as many points as possible, right? The line should get drawn in that way. That is what we call as the best fit line. So the actual and when you see the with the best fit line, if you compute the actual and the distance between actual and predicted value, it will be less. Okay, again, it depends on your data set also. Okay, but in general, if your sample size is bigger, it will be good. If your sample is very small, with a small data set, you cannot expect a lot, a lot of things, because your model should learn a lot of patterns from the data. Hence, obviously, you need to have a lot of data in your training data set. Okay. Hope you understood. We have gone step by step. First, we started with understanding the simple linear regression. Because simple linear regression, we have to use only one independent variable. But in reality, we don't use only one independent variable. We use more than one independent variable. Okay, fine. And then we proceeded with understanding what is intercept and what is slope. And with the intercept, we should be able to understand what is the value of y when x is equal to 0. And also slope tells us what is the rate of change in y when x changes. This also you can quantify it with the help of slope. This is what I mentioned. So this is my actual. The blue colored one is the actual auto fare, and this is the predicted auto fare. Okay, this is the predicted. The difference between, for let's in our case 3 4, right? Let's say 4 data was given by my manager. For each and everything, I just applied my model. So it gave me the predicted value for each corresponding records, and the actual values we know very well because it was given by manager. The distance between actual and predicted is called your error. You remember this thing: the lesser the error, better the model. lesser the error, the better the model accuracy. Simple example. Okay, somebody is asking you, hey, I want to buy Infosys stock. Listen, I want to buy 100 stocks. Can you tell me what is the estimated return on investment? How much can I get profitability? Let's say, you are predicting him. Okay, if you buy 100 shares now, so this is the return you can expect. Let's say, you can expect, let's say 1,000 shares he wants to buy. You say you can expect close to 100K, sir. But after applying your model, if your model, let's say your model gives 100K, let's say when he tries to sell in reality, he bought before he invests the money, he was using your model. With that, he could see a predicted return on investment, right, is 100K. So after he purchased the 1,000 shares, and then he decided to wedge his shares. Okay, in that case, what will happen is the actual price was not 100K and it is going to be 110K, or let's say it is going to be 90K. So what will happen, right? He is a loser, right? So there is if the model accuracy is not good, because in this case the model was not predicted correctly. The model predicted 100K, but my actual price which I sold it, right, for the 100 shares, I bought 100,000 shares and I sold it later point in time, I was able to get only 90K. So 10,000 rupees I incurred loss. Another classic example is something like the same thing, advertisement. Okay, if I advertise on television, and if I spend 1,000 or let's say $10,000 US dollar, what is the expected sales? And if you tell him it is going, you can expect 10% increase in sales. But after, let's say, you tell him after 1 month you can expect 10% increase in sales. But what happens? Not after 1 month. After giving the advertisement, we can expect 10% increase in sales. But if he sees only 2% increase in sales, then your predicted value is not correct. The accuracy, prediction accuracy is not good. So when it comes to any machine learning model, accuracy matters a lot. Accuracy matters a lot. The another class of even our day-to-day life, maybe it is not the correct example. See, for example, for your building or for your entire apartment, you want to do a painting. Okay, you call some painters and you ask them to give a ballpark. How much it will cost me to paint the whole apartment? He says, sir, it will comes around 8 lakhs. Comes around 8 lakhs. And he says, this is the estimated price, sir. This is the estimated price. And if you see the quotation given by them, you can see that, below somewhere they would have mentioned, there is a plus or minus 10% the increase in price. Okay, this is what they say. 1 second, please, sir. Somebody is knocking. Sorry, I got someone knocking at the door. Okay, this is the plus or minus 10%. Okay, this is not a definite estimate, right? This is not a definite estimate. This is called ballpark or estimate. Estimate is nothing but ballpark. Okay, And see here, the simple example is, after, let's say, you agreed for everything, you signed the contract, and when they do the painting on your building, let's say, they have completed 70% or let's say 60% of the painting, and suddenly they come back and say, sir, our estimation was wrong, okay, and you need to pay 16 lakhs. What will happen? What will happen? You will get, you will get annoyed, right? This is going to be a serious issue. But you said plus or minus 10%. Now you are saying 100% increase in the cost. So then something wrong with your estimation. They say, yes, sir, so something wrong with my estimation. If you pay the remaining 8 lakhs, you will complete the painting for the whole apartment. It's a serious issue, right? If the estimated value is not in line with your actual value, right? Yes, 8 lakhs, maybe what we plus or minus 10 is something like, okay, around 10 lakhs. We'll have to shell out 10 lakhs. We will keep 10 lakhs in our pocket, in our bank as a reserve, so that we will, in case if something goes high, more than 8 lakhs, we can still manage. 10 lakhs is there. And if they say suddenly 16 lakhs, double the time, then you are running out of money. Then whatever the estimation given was wrong. Now you understood how serious the accuracy, right? The accuracy is very much important. With this simple example, you understood the accuracy is very much important, especially in the case of stock market and every, and even in the case of classification model. So far, we are talking about regression model, and we have something called classification problems. So even in that case, accuracy matters a lot. If my model wrongly predicts a person who has no cancer, but it predicts wrongly cancer, then he has to undergo unnecessarily chemotherapy. Okay, the accuracy matters a lot. If you take any types of artificial intelligence models, even in the case of self-driving car, the wheel, right? The wheel, they call it the wheel, the steering, the self-driving car. So it has to estimate in what direction it should turn the wheel. When it should turn, and in what direction it should turn, and in and what angle it should turn the wheel. If there is a slight deviation in this, right, the accuracy, what will happen? It will go and hit the vehicle which is close by to it, right? So the accuracy matters a lot in the case of machine learning model. So here the error, let's say the error better the model. So what is error or residual? They call it as the actual minus predicted. This is my actual and this is the predicted. What is the actual? Actual was the actual stock price was 1,000. When I sell it off my share, it was 1,000. The predicted was they predicted it as 800, but still it is 200. It is good only. Okay, so but there is a variation, right? Variation here. Or for example, if it is going to be 990, the variation is very less. The model accuracy is good. So somewhat near close to 1,000, it predicted. See, this is the one before he invested the money, we predicted and informed, hey, you can expect 990. And he was able to sell it to 1,000 rupees, right? After we give this value, estimated price, stock price, he purchased it and then he sold it off after a few days, and he sold it to 1,000 rupees. So his profit was 10. But the difference between the actual and predicted is just 10 only. The difference is something like, the actual was 1,000, the predicted was 10,000. So there is a serious difference here, right? The accuracy is not at all good. Now you are with this example, you understood how serious the accuracy, right? Accuracy is very much important. So now we have understood what is the line. This line is called your best fit line. This line is called your best fit line. It is also called as your regression line. This is what your linear regression equation. Y is equal to beta naught plus beta 1 x. Okay. And plus x1 plus beta over 2 x3. This is what your multiple linear regression. This is the equation for your line. The best fit means the difference between actual and predicted values a minimum. Okay. And we have something called least squared sum of squares, and least squared sum of least squared. We have least squared method, which minimizes the sum of the squared differences. SSC, we call it sum of squared differences. That I will discuss it with formula tomorrow in detail. Okay, and also we will discuss with some scenarios. Okay, and scenarios tomorrow. So any questions so far? Intercept and slope, hope you understood, right? That is very important. And then what is the best fit line you understood? And okay, and how this best fit line is drawn? The next question is how this best fit line is drawn. Okay, the line is drawn here. What is the basis for the best fit line? Can anybody give me the answer? What is the base? See, here I have mentioned this is the best fit line. Yeah, somewhere you can also draw a line somewhere here also, right? What is the basis for the best fit line? So that means this is that's why I mentioned the definition. Best fit means the difference between actual and predicted. So here on this red color line, all the predicted values will be there. The distance between actual and predicted values should be less. The line which you are drawing, right, we should cover as close to as many data points as possible, so that the difference between actual and predicted value will be minimum, right? So here in this case, what we do is we are going to square the errors. Okay, sum of squares, so actual minus predicted value square. We will see why we wanted to square it, because you are giving answer, Aruna, where it has a slope and different values of our values and predicted values. Okay, you are giving an answer. Okay, or asking question. Slope and different values of our values, predicted values. Giving answer. Okay. See, the answer to the best fit line is the line which covers as many data points as possible. Okay, that is what your best fit line. Okay, it should cover as many data points, as close to as many data points possible. That is what your best fit line. Okay, so supposing if I draw the same line here, what will happen? It is biased, this line is maybe closer to these data points, but it is too far for these data points, right? If I draw a straight line here, you just think this way. If I draw a line here, what will happen? So these values are very closer. This is very closer, maybe closer, but these two, these values are falling far from this line. I can draw another line somewhere like this, right? So this is determined automatically by the model. And somebody is asking in the interview, right? In the case of finding the best fit line and all, right? It finds out the average value of your x-axis. This is another way of finding out the best fit line. This is the average. Average is there in the middle, right? This is your average. This is your y value. This is your x value. X bar is your average, where the x bar and y bar intersects. This is my y bar, and this is my x bar. The average value of x and average of y value, where it intersects, that is where this line emanates. If somebody is asking you in the interview, what is the best fit line, you can say this way also. Instead of saying the line which covers as many data points as close to the line which covers as close to as many data points as possible is my best fit. Instead of saying this way, we can say this way also. The average value of x and the line where it intersects, okay, the line where it emanates from the intersection of both the average of x and average of y. So in the case of independent, simple linear regression, it is fine, right? If you have multiple independent variables, right, it is something like a plane. If you have it's like more than one independent variable. That is what your plane. Okay. See, there are two things. One is, what do you mean by best fit line or ordinary least squares method? Okay, what do you mean by ordinary least squares method, or how does the best fit line is determined? in the case of linear regression model. Like I said, right, we can say the statement like the line. See, that's what I just phrased it in the simple English. The line which covers as close to as many data points as possible. That is what my best fit line. Okay, mathematically, if somebody is asking you, okay, so in that case, mathematically also I can tell them. So line, the best fit line where it emanates from the intersection of both the average of x and y value. We can say that we also see. This is the one I'm talking about, right? This is where this line goes, touches this thing, right? It touches this and it goes out this. Okay, this is also called as your best fit line. You can say this way also. And another question is, okay, in this case, your x bar and y bar, you are saying that, let's say your x1 bar, and let's say you have more than one independent variables are there. So in this case, you have something called, let's say television, and you give ad in Facebook also. Okay, this is another axis. Let's say, this is x, y, this is z. This is your independent variable. These two are your independent variable. So in this case, if you have more than variable, it's like a plane. Okay, because for single variable, drawing one line is fine. It's a plane. Even this plane also, it covers the same logic. The same principle is applicable. It covers as close to as many data points as possible. That's how the plane is drawn in the case of multiple linear regression. So in the case of next question is, what is ordinary least squares? Ordinary least squares, the actual minus predicted. So the actual I call it the y, and the predicted is my y hat. V is this node, but we square it. Why do we need to square it? Because if you add each and every error, take for example in the case of auto fare, predicted auto fare, right, for 5 different distances. You get for a specific distance, and they have given you the actual price and the predicted price, this one, the error one, and whatever the errors that you see just above the lines are positive errors. Whatever error you see just below this line are your negative error. End of the day, we need to know what is the total error, sum of error, right? But when you add the positive value with the negative value, the plus and negative will get subtracted. Do you remember in standard deviation what we do? In the standard deviation formula, what we do? Okay, I don't want to talk that now. The actual minus predicted. Let's say my error is 10, but here my error is -2. The predicted value is 12. The actual is 10. 10 minus 12 is -2. When you add plus and minus, it will get subtracted. I don't want that to happen. Hence, we square the values. Okay, 10 squared, error 1 squared, and error 2 squared, 10 squared. And if I square this one, error 2 squared, -2 into -2, I will become 4, right? And then sum of squared error is equivalent to 10 squared plus -2 squared plus, let's say I give some other value. Let's say this 3 squared, and here I give -3. 3 squared plus -3 squared. This is called your sum of squared error. Right? This is called it is sum of squared error. It is also called as ordinary least squares. The least squared minimize the sum of the sum of the square differences. The least squares method minimize the sum of the square differences. See, the other way of thinking this one is very interesting one. Listen very carefully. So I have drawn a line here. Listen very carefully. It's very interesting one. See, the actual and predicted, you are subtracting the, right? You are subtracting this. You are getting that error. Let's say the error is 10, 10 squared. If I draw a line, here, I get something like that. If I draw another line here, right? So that in that line, the predicted will be here. The actual value is here. For that line, what is the sum of squared error? See, like this single line, I can draw any number of lines, right? I call this as A, and I can draw another line. I call this a B. I can draw another line C. What is the sum of squared error for this line A? What is the sum of squared error? Error for line B. What is the sum of squared error for C? Can I find out or not? Simple here. See, if you draw a line, you can find out, right? Are you able to understand or not? Okay, I will just, you're not able to understand. I'll just, that's why a lot of concentration is required here. See, take this example. I'm going to, let me do one thing. I can draw a line here, somewhere here also, right? And I can draw somewhere here also. Okay. So the predicted values are there on these three lines. Okay. Now I call the A and B and C. What the sum of, they say the sum of, now you tell me where the sum of squared error for which line is more? Which line is more? Simple common sense, use common sense now. See, the line A is closer to this value, but it is not closer to other values, right? You don't have to do math here. Okay. See, the predicted values are there here, and don't ask me what is the predicted value, what is the actual value. Only when you give me, I can tell you. See, simple common sense. Look here, if I draw a line here, this line is very close to these three lines, right? If I draw a line here, it is closer to these values, but it is far from these values. This is far from this. Guys, please try to understand. But when you go to real-time job, they will expect you to be very smart. Okay, see here, right? These values are too far from this line. So the line A, right? So of these three line, which line is better? Aruna, excellent. Aruna gave a correct answer. Aruna has no technical background. Very good. She has picked up like it, right? So the line B is, see, this is closer to this one, and this is closer to this one, right? And this line is closer to this one, and this line is closer to this one, right? And but it is little far. But if you take this line, this is very closer, but it is too far for this thing, right? If you have some observations here, it is gone. Or you see, if you have something else here, right? Predicted value is here, and it is too far, right? So here it is better, but line B is the best one, right? Line B has line B, right? Yeah. So you don't have to compute the actual and predicted. And see, this is my error one. This gives me E1, E2, E3, right? E2, E3. And for line A, E1 squared plus E2 squared plus E3 squared. And similarly, B, C, same thing, E1 squared plus E2 squared. What is the error? Since this line is somewhat closer to all the values, obviously line B is the winner. So this is the best fit line. So here they use the least squares method, right? That is what your least square method, least square, least squares method, ordinary least squares method. In the case of ordinary least squares, it fits the best fit line by in such a way to minimize the sum of square differences between the or their sum of square differences. Okay, it minimize, or in simple terms, least square method minimize the sum of square differences. So we can use the ordinary least squares method to, in the case of linear regression model, ordinary least squares method is used to minimize the sum of square errors. Okay, and we have other technique that I will discuss it later. Okay, so using which also we can minimize the error. The whole objective is minimize the error, minimize the error. Okay, that is one of the common objective in you take any models. Okay, it's a deep learning or anything. reduce the error. That is the whole objective. Okay. Obviously, your accuracy should be good. That is the reason why we are going for building a model. Next one is feature selection. One second. Before I jump in there, let me check the logical flow is correct. Yes, everything is correct. The flow is correct. But only thing is we will discuss in detail the metrics and feature selection, everything tomorrow. How do we validate the model? Everything we will discuss it tomorrow. And before we jump into the feature selection, I will just take a quick digression and I'll explain you in real-time scenario, how do we train the model? Okay. Supervised model, supervised machine learning model. Supervised machine learning model, how do we train them? So you have the linear regression model. What is the linear regression model? The equation here, that's all. Y is equal to beta naught. This is y. Y is equal to beta naught plus beta 1, x1 plus beta 2, x2. This is what your independent variable. You have more than one, right? You are training your model. Right. So training in the sense we are teaching the model. Okay. So what we do is in the case of supervised machine learning model, not only linear regression, almost all the algorithms, right? Or the common principle is you need to split your given data into training and test data set. Let's this is your data set given by someone, right? Or your manager or some stakeholders, they've given you the data set. You need to split this into train and test data set. Okay, and some cases what we do is we split the data into three parts: train and validation and test set. Okay, let's say this is my 60%, 60% and 20 and 20, something like that. Okay, this is 100% data. I'm going to split it 60 for training data set, 20% for validation, 20% for test set. Some cases 60-40. Train set is 60-40. Now the question is, why should I split the given data into train and test set? The reason is we use the training data set to train our model. Obviously, this data set will also have both independent and variables, and then you will have the labeled output variable will be there. Since it's a regression model, your actual value will be there. Okay, independent variable and dependent variable will also be there. Okay, the historical data. Let's say this is the historical data set. And you splitted this into train and test set. In some cases, what we do is we split it into train and validation test set, and we'll discuss this a little later. And let's start with this one. In this case, 60% data is splitted for training set and 40% data is splitted for test set. With the 60% of the trained data set, we are going to train the model, which means we are going to teach the model. We are going to show this data to this model. Okay, and we are going to show the data in the sense it will obtain values for the beta naught and beta 1 for this given data set. Okay, and then what we do is the learned model, right? We apply the learned model on the unseen data. Unseen, in this case, the test data. So apply the learned model on the unseen data, in this case, the following. See this, whatever the data that are there as part of this one, we did not show it to this model while training the model. Okay, this data was not seen by my model. Okay, so we apply this model on the test data set. See why we need to, this is called your cross validation. What do you mean by cross validation? I train my model using the training data set, and then what I do is I check the model accuracy. Don't ask me what is accuracy here. There are some metrics. we have something called R squared, adjusted R squared. In the case of multiple linear regression, we'll discuss this in detail tomorrow. Okay, adjusted R squared. Okay, so with this, we will understand what is the accuracy model. Let's say if the accuracy it shows you somewhat closer to 90 or 92, you are lucky. Okay, my model accuracy is 92. You can raise your collar or you can roll up your sleeves and say, hey, my accuracy is 92. But what they will ask management is, okay, since you trained your model on your training data set, it gives you 92. Why don't you apply your model and ask your model to predict the same for the test data set and then tell me what is the accuracy for the test data set, right? So when you apply the model on the test data set, and if you get something like the accuracy or the adjusted R squared, or we call that as the error, okay, sorry, adjusted R squared, right? So we can find out the adjusted R squared for, let's say the adjusted R squared is this one. Let's say you get something like 80. So which means my model is performing very well on the training data set, but when I apply this on the test data set, the model performance is not up to the mark. There is a gap here. There is a difference. It need not be same value. So for example, if it is 90, then it is fine, or 88 is also, there will be some, difference. It should be minimal. The accuracy, okay, the training data set accuracy and test data set accuracy, there should be some difference. It need not be exactly same, but it should not be, this much and all. Okay, 80 and all, not acceptable. That means your model is overfitting. This is called overfitting. Okay, if your model accuracy is opposite, let's say you're 80 and you're 92, underfitting. Underfitting. That means your model has not generalized well. Generalized well. Say the exam, the classic example is exam. You prepare, let's say in the upcoming semester, what you did, you collected the model question papers and answers from your previous batch students, right? Your seniors. And then what you prepared for that, and then now you're appearing for the exam. You already learned it. You know the answer for the question given in this exam, current year exam. But since the question was a little bit tricky, you're not able to answer it. You got confused. But when I give the same question, you will answer it correctly, right? Because that's what overfitting, right? Your known thing, right? Because you are already known to that questions. If I ask the same questions, you will do it. If I ask the same questions different way, you're not doing good job, right? So, right, you are, that's what called as overfitting. In the training data set, you're doing good, but the test data set, you're not doing good job, unseen data. So overfitting, okay. And what is underfitting? Underfitting is something like, right, your model is not performing well on the training data set, whereas it is performing well on the test set. There is some problem with this, your model. But ideally, it should be somewhat closer. See, if it is a 92, here there is a 5%, 5% variation. In the interview, they'll ask you the real-time scenario questions. So, what is your model accuracy? How did you test your model? We did some cross-validation with the test data set, and the test data set volume was 40%, and training data split was 60%. And with that, we applied the train model on the test data set. The difference was just 5%. That means, it is not overfitting or underfitting. Your model did not memorize. It was able to generalize very well. It was able to generalize very well. Memorize means overfitting. You are, memorizing the value. You are simply memorizing the questions. The same questions comes, you are lucky. Or the same question, but if they ask in different way, you are gone, right? That's the overfitting. Okay, But it's a machine learning model, or you take any model, okay, it should generalize well. It is our response to make sure that the model is generalized very well. So in order to make sure that we conduct the cross validation, we perform cross validation, we apply the trained model, the unseen data, and also we compare the error. Okay, so usually we use the SSC, sum of squared error or mean squared error. What is the mean squared error for this test data set after applying the model on the test data? Not the mean squared error for the linear regression model, for the training data set. So don't worry, when I give you a demo in Python, you will understand very clearly. That's what, when it comes to the algorithms, right? When you start practice it, you will be able to understand. But initially, when you understand three algorithms like linear regression, logistic and decision tree, the rest of the algorithms, you don't have to spend too much of time. But you need to spend quite a time with these three algorithms. Once you understand, that's all. You'll be able to understand the rest of the. But neural network is slightly different. Don't worry. Even unsupervised machine learning is also different. But majority of the supervised machine learning model you should be able to understand quickly. But with these kind of things, so this is very common thing, which means splitting the data into train and test set. This is a very common thing. Okay. Sometimes what will happen is even after splitting the data, my model accuracy is not good, and then I have included some additional columns into my existing independent variables, but still it is not doing good job. I trained all possible combination, nothing is happening. What you do is in that case, right? So that's why what we do is we do split the data on three different parts: train set and validations and test set. With the training data set, same thing. We do train the model. That's all. And validation set, why we use a validation test to fine tune the model parameters. We have something called hyper parameters. Right, for that purpose, we keep a separate copy of the data to fine tune the model's hyperparameters, and then we test it. Okay, so for that purpose, we use the three different splits of the data. Okay, and at this moment, we will focus on train and test set and how we can train the model, all the things. But before I jump into the tomorrow, what we will do is we will start a little bit on the hands-on part. If I keep talk on the theory part, it will be boring. And then will help you get into understand what is adjusted R squared, what is R squared, the model output. I will explain it side by side. Okay. Any questions so far? But you need to watch my video. Okay, the effort should be constant. Okay, you need to put your effort constantly. Don't give up, and don't think this is different and the YouTube is all different. Same thing. You go, maybe they are using different examples. That's all, right? But study material. Only thing is, this is somehow I was able to get it somewhere. I kept it. I put it there for reference purpose. You can go and watch it in my website, and videos also will upload it today itself. The thing is, yeah, fine. Okay, any questions? Okay, see you in tomorrow's session, same time tomorrow. And regarding the timings, right, we will discuss it later. I will see to that. Okay, but still I'm feeling weakness, and in a 2 or 3 days I'll get back to you. Okay, so most of them prefer between 4 to 6 p.m. evening. After 6 p.m. it's difficult, and we will try to make it 4 to 6. Okay, and next week let's wait for some time. Okay, I'll confirm that on this Wednesday. Okay, I'm going to end the session since I don't see any questions. You watch my video, and then watch other videos whatever I uploaded so far, and complete the assignments in the meanwhile. See you tomorrow.